Hi everyone, my name is Sophia Howe and I'll be presenting my project on determination of ionization constant of a weak carboxylic acid via freezing point depression measurements. This is the outline for today's presentations. And carboxylic acid is a weak acid that partially ionizes in water because due to its equilibrium constant of the acid is less than 1. So in this figure we see that in strong acid the ions are separate completely. However, in the weak acid, it's being separate partially. So this will lead to the derived equation method of calculating the equilibrium constants and the ion of the carboxylic acids. So here we will be determining the A, and then using the A to define the I minus 1, and then we will substitute into the equation to determine the Ka value in each concentration. The freezing point depression is impurity reduced at the freezing point of the solvent based on the temperature difference of a solution and the amount of solid concentrations. So the apparatus that is being used in this experiment is using a log report software, kilometers, temperature sensor, test tube, acetone, and various carboxylic acids. So the procedure for this experiment is we use ice, acetone, and salt in the kilometers, adding 2 to 3 distilled water into the test tube and measure with the temperature sensor for the freezing point depression. We stir the test tube into kilometers with ice, acetone, and salt until the temperature is stable and the water in the test tube freezes. So we will prepare the concentration of each concentration of a carboxylic acid and repeat the procedure as it's being said with the substitute with the salt. And then we will record the temperature depression and calculate the equilibrium constant of the acid values with by the direct equations. So here is the end result using maleic acid as a carboxylic acid, and then here is the ion that is being formed, being calculated, and also the Ka values that is being calculated in each concentration. There is 5 concentration in 0.05 molar, 0.1, 0.25, 0.5, and 0.75. This is also going to be calculated with the same in malonic acids, ion, and the equilibrium constant of the acid in each different concentrations. And also same as oxalic acids. And for the future studies, we will continue with the different acids at different concentration with chloroacetic acid, glycine, dichloroacetic acids. And in this conclusion, to wrap up our presentation today, is that the Ka value must be higher than 10 to the minus 3, and the ionization can be determined based on the freezing point depressions. And this is the first time we experiment at 0 degree of the freezing point method to determine the Ka value of the carboxylic acids. And basically this minimize a lot of ways by comparing to traditional methods. And this experiment is extremely fast and simple that can easily be reproduced. Here is my reference acknowledgements, and thank you so much for listening and any questions.